So if you got a ruler, or just make your best effort here to get a dashed line.
Got it.
Got it. Okay, and then we have to decide whether we're going to shade above or below. Can you tell me that based on?
Below.
So greater than is above. This other way is below. It also corresponds to the
above.
Yeah. All right. Now, rather than shading above, what I do is I just draw little arrows just to show that it's because we're not sure how the rest of it's gonna look, and you want to kind of hold out before doing that. So just some indicator that you know which side it's going to be on. Any questions on that before we move to?
Oh, I got that. Yeah, that's good.
So the nice thing here is that like in terms of what we did last week, like you'd be done. Or last Thursday, you'd be done.
Right, yeah.
Now we're just rinse and repeat. We're gonna do the same thing here again. You got to find the slope and the b value. We got to graph it, solid or dash, shade above or below. And then there's a tiny little, final point on that. What's the slope? What is the b value for this new one?
The slope is 1/1.
Good. And the b value?
0,1.
Yes. All right, so b value, we start there. Rise over run, up 1/1, up 1/1. Is this one solid or dashed?
Solid.
Solid. Okay, so we're in really good shape here.
This is below.
It's below, so I'm going to draw little arrows kind of below. Depending how clean your drawing is, how good your handwriting is, it should be pretty clear. There's 4 regions. There's this one on the right, this one up here, left and bottom, and it should be pretty clear which one is the intersection between the two based on your arrows. Down and to the right, this is there.
Got it.
If you're not sure, go back and redo the steps, and because you don't want to shade and then erase and then shade, it gets really unclear. You want to make grading easy on your instructor, because they're people too. They want to spend as little time as possible grading this, so don't make them wonder what you're doing here.
Got it.
All right, lesson's over. You got it. I mean, unfortunately, there's a few variations on this, but we'll do number 5 next because it's kind of the most similar, and then we'll move to some other problems that are got a few other things to look at there. Any more time? Do you need more time on this one?
No, I got it down.
Okay. All right. So we're going to look at this equation by equation. Look at that first one there, less than or equal to 2x plus 3. What I would recommend you do is find the slope, find the b value, graph it, and figure out which side to shade. So I'd like you to do that. Take a couple minutes here. If you have questions, please ask, but I'll draw it here after you're done kind of working through it. See if we're in the same wavelength.
All right, I got it.
All right, so the B value is 3, the slope is 2/1. It's a solid line because of less than or equal to.
Yeah,
So it should look something, like this, and then you're shading below, which is underneath. So something like this, where you kind of know that direction. Does that look consistent with what you have?
I got all that. Yeah.
Excellent. Very good. Now, the next one, this is something they can do to be deceptive. They can put this in the wrong order. Like what you really want is the variable first and then the constant second. And you should rewrite it. You should make it look like something you are familiar with. Okay. They're only doing that just to make you write the wrong number for the slope and the B value because you're not paying attention. So same thing for this one here. Go ahead and determine the slope and B value, graph it, solid or dashed, figure out which side you're shading.
All right, got it. All right, I got it.
Okay, so you're starting, and I'll do a different color this time. Starting it in -1, up 2, right 1, up 2, right 1. It's a solid line. Yours looks something like that.
Yep.
Okay. Now you should notice right away, and I should have said this earlier, is that these are parallel. These are parallel lines. And in terms of which side you're shading now, you're shading above. Okay, so you're shading to the left here. The left only because it kind of looks more left than above, but it is above. Okay.
Okay.
And now this one's different because there's there's actually 3 regions this time. 2,
1, 2,
3, not 4. You're looking for the overlap, meaning where they're both true. So that's everything in the middle here.
Yeah.
So the other possibility, and you actually see that in the one top in your example here, which I'll just snip in so we got some context, is that it could be outside. Like these two I consider to be outside,
Yeah.
and this one is inside. It's very similar to the compound inequalities where we had a between and then an outside case. If you don't remember, that's okay, but that's kind of what's going on here.
I remember that.
Okay, we've done a couple problems now. Any questions? Because all we're going to do from here is just variations on the same thing. Really nothing different, but we
No,
got some
I'm
more
good.
problems to do. Okay,
I'm good.
great. All right. So new problem here, number 3. We will go back to number 1 at some point. It's you'll realize how simple it is when we get there. I want you to graph the first one, and then we'll talk about the second one. So same thing, slope intercept, checklist there, just knock it out and let me know when you're done, and I'll graph something similar.
All right, I got it.
All right, so starting at 1, it's got a slope of 1,
Yeah,
and it's a dash this time.
right.
All right. And are you shading above or below that? Above or below?
Below,
Below.
got it.
All right, so we got to get that a little more certainty on that, but that's great.
Yeah,
Okay, now the 3x plus 4y, and I'm going to write it just this way for the moment, equals 12. There are two ways to graph this. Way number one, and I'm not giving you this not in any particular order. Way number one is to solve for y. Okay, that's slope intercept form. That's, I think, what we've been doing mostly. What I'd like to do is show you the other option, which is to determine the intercepts. All right, and to do
right,
that,
yeah.
if you don't like it, you know, we'll just not do it that way. But you'll find that in certain problems it does work better.
All
So the
right.
first thing you're going to do is you're going to set x equals 0. So when you set x equals 0 in this equation, do you agree that the 3x goes away? 3 times 0 is 0.
Yeah,
So it's just 4y equals 12, y equals 3.
Yep.
So that's a point. That's 0, 3. Okay, that's that point right there.
yeah.
We're similarly going to set y equal to 0. And notice back here in the original equation, 4 times 0 is 0, so it's really 3x equals 12, x equals 4. That corresponds to 4, 0. So that's that point right there. Okay, so what do you think of that approach? Do you like it? Do you dislike it? Not
No, I
sure.
like that. Yeah.
Okay.
That's easy.
It's better in certain situations. It works really well because both 3 and 4 go into 12. That's one of the reasons here. The one disadvantage here that you're going to see shortly is that it's a solid line here between them. Is how do we decide whether to shade above or below? And you might think, well, because of this symbol here, greater than or equal to, you already know the answer.
Yeah.
That is wrong.
Oh,
That is wrong. So I left this out, and I'll just do it right here. You can only shade below when you solve for y.
mm,
You have to solve for y. Okay, and we hadn't done any examples where it was different yet, so I didn't have to bring that up. But you know, math is full of exceptions, full of caveats.
yeah.
So you can only shade above if it's solved for y. Do you remember the other approach for deciding whether you shade above or below that we've talked about?
I don't think so.
Testing a point.
Oh, yeah. And plugging in and seeing if it works.
Yes.
Yeah. Okay.
So when you don't solve for y, you do have to test a point. So you gain the fact that it's really quick to get the intercepts, but you lose the ability to just shade on one side or the other. All right, so you have to test a point. You typically test 0, 0. So we'll do that down here. 3x plus 4y greater than or equal to 12. We're going to test 0, 0. 3 times 0 plus 4 times 0. Is that greater than or equal to 12? What do you say, true or false?
False.
It's false, which means that you don't shade that side. You shade the other side.
Shit, the top part or the.
Yeah, the above in this case.
Yeah.
So you might think, oh, well, it's greater than or equal to, I just shade above. Like, no, you
Yeah.
really, easy to misremember that. So now the overlap between them is again over here. So when you're being graded on the test, they're looking for, did you graph the correct line? Did you graph solid and dashed correctly? Did you shade the correct region?
Those four. Is that 4 points or 3?
I don't know. I'm just sort of
I
saying,
think it's 4. Yeah.
yeah, just sort of generalizing.
Yeah.
So you kind of know that if you're ever unsure, try to go back to, okay, did I graph the lines correctly? Are they shaded, solid, dashed, all that stuff. Okay. We got tons of time here. Let's do number 4 next.
Can I start it?
I want to ask you a question before you
Oh,
start.
wait. Oh, yeah, this one's different.
Yeah, they're all just a time. When we look at that top equation, if you're like, hey, you're thinking, okay, I'm going to use the intercept approach, which is always a good approach, and you can use it here. It's best used when both 2 and 1 go into this number evenly. Okay. So since it doesn't, I mean, you can still use it. It's good, not great. I would recommend solving for y to keep it simple. Keep it like we've been doing.
Okay, so make y 0,
No, solve for y.
make x 0.
Make it so that y is on one side of the equation,
Oh, okay.
which means to move the 2x.
Yeah, I gotcha. All right, so 2x. Subtract 2x to the other side.
Yes. And I recommend putting it in front of the
The 1.
the 1, yeah. Okay, so now go ahead and graph it, solid dash, figure out where you're going to shade it, all that stuff.
Y is solved in this case, right? So I can determine it that way.
Yes, I could tell there's some confusion there. Solve for y means to get y, or the variable, on one side alone. Nothing
Yeah.
else, no number in front of it, no other constant, no other variable. It's the only thing you see. If you ever moved, it's like getting everything out of your room except that last item. It's like, that's it, nothing left.
I have my points on the graph. I just don't know if my line is
Okay, so your slope is -2 over 1, your b value is 1. So
yeah,
there it is, down 2, right 1, down 2, right 1, down 2, right 1. And
yeah.
it's a solid line this time.
Okay.
Okay, now the advantage of solving it for y is that you can immediately tell me whether you're shading above or below. That's one reason to always solve for y. Are you shading above or below here?
Below.
Let's go back and look at the rules. Got to get these down. Greater than or equal to, greater than is above, less than or equal to is below. If it's solved for y.
Greater than is above. Okay.
Now, I'll tell you that you can test a point still. Like, let's say you wanted to test 0, 0. Okay. And
Okay.
since we just decided it's above, this should not work. Okay. You can test it either in the new one or in the original.
Let's test it in the new or
Okay.
the original.
Original's fine. 2 times 0 plus 0, is that greater than or equal to 1? Is that true?
No.
No, and we don't want it to be true because we already know it's supposed to be above here.
Yeah.
They are consistent.
Got it.
So there's a phrase, I'm trying to think of it here, but it's like sometimes you get too much information, too many options, and I'm not trying to be unclear. I'm not trying to like make it so that I'm trying to show you these all work, but you have to decide which way you want to do it.
Yeah. I gotcha.
All right. Now for the second one here, this one's pretty tough here because it's got some things that we don't like here. I'm going to first solve for y. Okay. And I'm going to do the intercept approach as well. When you solve for y, you first subtract x from both sides. Minus y greater than or equal to minus x minus 2. And this is a problem because we're not done yet. Y is not by itself. It's got this negative out in front. It has to be completely alone. So you're going to divide by -1 everything. But what does that do to the inequality? When you multiply or divide by a
Everything
negative,
stays the same. It's just now all equal.
it's flipped.
Yeah. And
Flipped.
everything's now positive.
Right. So more to remember. So if you're like making a pro-con list, you're trying to decide on this. This is another disadvantage. Is like when you solve for y, you may have to flip the inequality, because if you don't flip it, your graph looks good to you. You think it's right, but it's not.
Yeah.
So that's, again, that's like, what do I do? Like, I don't know. Matt, lots of options here. Slope is 1/1. B value is 2. Okay.
Got it. I'm going to start graphing.
Yep.
This is a straight line, right? Not
Yes.
dotted. All right.
Solid, because of the line underneath. That's what tells you that it's solid or dashed.
Yeah.
And then you are shading, because it's a less than, you're shading below. So below, 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 below. So a lot of these, strangely enough, have been sort of this one off to the right here. Any questions on that?
No, I got it.
All right, so one final thought on this one. If we use the intercept approach, it would be x minus y, and then you just set it equal to the number. You don't use the inequality when you do the intercept approach. But if you set x equal to 0 now, if I was there right in front of you, I would put my thumb or cover up this x, but only the x that you would see that it's minus y equals -2. That minus goes with, subtraction goes with the y. So it's not always that you're done. You do have to sometimes make some additional steps here. Y equals 2. That's 0,2. If we go back to our graph, we see that that is one of the points there. So it is consistent. Similarly, if we set y equal to 0, -0, subtracting 0, adding 0 doesn't affect anything. So this time x equals -2. And we've got another point, -2, 0 on the graph, x before y. Go back to our graph. There it is. Connect them. It's the same. But you then have to decide, is it above or below? That's where you probably have to end up testing a point in this. All right. So I typically try with students like you to draw some analogies to sports, especially if you're a sports guy. Like I'm not really, I mean, I played baseball growing up, but I'm not big into baseball. So like, it's kind of like, for me, it's more like a basketball analogy, like the type of defense you might play. Do you go man-to-man, zone defense, something else? There's pros and cons to all of them.
Right.
And that's really what you're like deciding here. Like you can do it the same way every time, but there's times when you're like, man, I wish I'd just done it the other way because it was easier. So you have to make a decision. Am I going to learn all of them? Just one really well, both? It's
Yeah.
kind of up to you.
I know.
Totally up to you. And I can't really help you with that. I can only give you the guidance to make that decision.
Well, we just learned both ways, right? This was the
Yes. Yes.
Okay. I mean, in my opinion, the first way is easier. They both make sense, though.
Yes. All right. Okay, so new problem here, number 6. I want you to graph the second one first on your own there, and let me know when you're done. Then we'll talk about the first one.
Second one.
Yeah, at the bottom one there.
All right, I got it.
Okay, so the second one here, you can do it just as is, dashed line, hopefully your dashed line, something like this, looks something like this here. Is it above or below that?
Below.
You seem uncertain. It's this one is above. Give me some feedback. Why do you think that that is not
No, I just get confused. I just can't really remember it yet.
okay?
It's just not in my head yet. I have to keep on practicing it.
That's fair. That's fair. And you can always test a point if you need to confirm that. Always go to the origin if you can. You have to test a point that's not on the line. You know, is 0 greater than minus 0 plus 1? Is 0 greater than 1? No. So that's why we shade the other side there on the right.
Got it.
Okay, when you look at the next one here, do you want to use the intercept approach? Do you want to solve for y? What do you see?
Let's solve for y. Let's get x over.
Okay, so I want you to solve for y. Take your time, ask me some questions, and we'll see where you're at here.
All right, got it. I have a question.
Yep.
So I did minus 5x, got it to the other side.
Okay, so it should look something like this.
Yeah.
Okay.
Now, what should I divide the -2 by? The 6?
You always your focus is on the side with the variable. Like your focus should be right here. You actually don't
Yeah.
even care what's going on the right.
Oh,
Your,
okay.
your goal is to isolate the y. So what do you undo to get just y? What do you divide by here on the left?
2?
-2.
-2?
It's got to be the same thing,
Yeah,
same number.
-2.
Okay, so go ahead and keep going. Work that out from here, please.
What's the -5x over -2 go out to? Does it stay the same or what?
The signs cancel and you're left with just 5 divided by 2 times x. And it's written this way where the x is off to the side so that you can see the slope.
5
It's
over 2.
yeah, 5 over 2.
Got it.
Let me know when you've got the rest.
Got it.
Tell me what you've got.
Y, less than, and then the sign, and then +3.
Like
Plus,
this?
or -3, -3.
Okay, okay. Is this what you have written on your paper?
Yes.
So the only thing that's slightly off here is this right here. And why does it flip again? What causes it?
Because of the division, or because of the dividing by a negative.
Yes, yes. Okay, now you have enough to graph it. All right, so
I got it graphed.
yep.
Should I tell you the points or what?
No, just go ahead and graph it yourself and then I'll
Yeah, I have it
oh,
graphed.
you got it. Okay.
Yeah.
So we're starting down here, up 5, right 2, 1, 2, 3, 4, 5, right 2. So we can't get, and this time is it solid or dashed?
Dashed.
Dashed.
Solid would be if there's a line under.
That's right.
the
That's right.
sign.
Yeah. Now, because it's already solved for y, you can shade above or below based on just looking at it. So this one is an above. Above is kind of looks like it's to the left, but that's above. And then you're looking for the overlap between the two. Does the overlap occur in region 1, 2, 3, or 4 in this one?
It's in the middle.
1, 2, 3, or 4?
Is that 4?
This one down here is 4, 1 to the right, 2 up here. Is that what you mean?
It's hard to explain this, you know what I mean?
Okay.
It's
So
on.
just hoping you give me the number. The number tells you that whole region.
Oh, do you mean 2 then?
Yes. Yes.
Okay. Gotcha.
It's you're going through a screen onto my screen, picture of the paper. I mean,
Yeah.
it's not great.
Sort of hard.
All right. So before we go back and do number 1, I want us to just have you solve a couple of more inequalities. So let's go minus 4x minus y greater than or equal to positive 8. So I want you to solve for y, please.
Okay. The X goes first, right? On the right side.
It's preferable that it be first. Yes.
Gotcha. All right, I got it.
You have it completely solved for y?
Wait, solve for Y. So
Yes, completely solved. Just y on one side.
yeah, I got that.
So just to be clear, I'm looking for y, some symbol. You got x, something with an x, and then a number over here. You've got that?
Yep.
Okay. So let me work this out here and you tell me same or different. Do you have minus y greater than or equal to 4x plus 8 for the first, just the starting point?
Yeah.
Okay,
Yep.
and you're going to divide everything by minus 1. Did you also do that?
Yeah.
What does that do to the inequality?
It flips it. So now it's less than.
Is this your final answer?
Yeah.
Okay, so let me give you one for real now to try on your own where
Awesome.
I don't, we're just looking at your final answer here.
All right.
Let's go 3x minus 2y less than, we'll just be kind here. Let's go 8. Not too bad.
Y is greater than 3/2x plus 4.
Like this.
Yeah,
Well done.
got it.
All right. So let's go back and look at number 1. Before we do that, actually, let me just a brief review here. If it's y equals a number, for example, y equals -2, this is a horizontal line that is always where, and I read it this way, y is always -2. That's the way I read it. And that's what a horizontal line means. It means the y value is always the same, -2 in this case. If it's x equals a number, an example would be like x equals 1. This is a vertical line, up and down, and x is always 1. That's one way to remember that. Okay, so if you get a note card or on a quiz, or this would be like important thing to remember if you don't have this down, something to think about, because for problem number 1, we are graphing both a horizontal and a vertical line.
Okay.
So we're going to do that here.
So that's why you were having me hold off on number 1, just because this one was a little bit different, because there's.
I consider it an exception.
Right,
If we were in the classroom, I might give you these first, but give you a bunch of these to get a feel for shading above,
Yeah.
below, left, right, to kind of build that up. But because it seems like you did this in the other direction where you're doing all the graphing first, I wanted to hold off on doing it. It's not a difficult problem.
Got it.
It's just, you need to look at this right here, and you need to say, oh, that really means y equals -1. And you're going to tell me now, is this a horizontal or a vertical line? Y equals -1. What do you say here?
Horizontal.
It's a horizontal. So it's a horizontal line at -1. So is it solid or dashed though?
Dashed.
Dashed, yeah.
Got it.
Now, are you shading above or below it?
Below.
So greater than is above.
Oh god.
So we're going
Oh,
above. It's
I
okay.
thought the negative. Okay, yeah. All right.
Negative has nothing to do with it. Once you get
Yeah,
you're
I
just
don't know
looking at
why
the
I
inequality.
Yeah. All right.
All right, so the second one here is x less than 0. Think of it as x equals 0. That's a vertical line down the middle here, like that. Because it's x less than, are you shading? In this case, it is left or right. There is no above or below.
Mhm.
So this means to the left. Where is the overlap? Is it in region 1, 2,
Down low.
3, or 4? Which one?
Wait, by that do you mean where's the two lines meet?
No, I don't. And that's what I think. I'm glad you said that, because now
Oh
I
yeah, I
understand.
was a little confused about that.
I'm asking where the shading overlaps.
Oh, in 2.
Yes.
Yeah, and I get it.
Okay. So in the time we have left here, which we don't have a ton left, I'd like you to just practice a couple of these. When you're drawing these, you can be much more crude with your drawings. Like, we don't have to put them on gridded planes. But let's have you graph x greater than or equal to 4, y less than or equal to 2. Okay. And I'm looking for two lines, shaded, or I'm sorry, solid or dashed, and then shaded in one of the 4 regions, basically. I mean, if you need to, you can think of a coordinate plane, but I'm more interested in that other stuff. So give this a try, see what you come up with.
I have a question.
Yes.
So I have my X graphed with my line.
Okay.
And I know it's above, but this is a left to right. So which way is above?
So on the y is the easier one. The y is above or below. For the x, it's left or right. So greater than in this case means to the right. I shaded that all wrong. Boy, that's terrible. Whoa.
Yeah, that's below.
Yeah. So even I make mistakes because I'm just
Okay.
clumsy sometimes, and don't be too hard on yourself if you did the same earlier in the lesson. Yeah, you get the 2, and this time you shade kind of top right there. All right, so we do have to stop there for today.